All right, so today we're continuing on with the recursive growth and decay. And so today we're moving on to what's geometric. So we did linear, wherein the linear goes up like so. So with geometric though, the growth goes like this. So it's not a straight line, it's a curve, so that would be the growth. And of course, a decay would go the other way. So and it curves again, not a straight line. Okay, so that's geometric. So with the geometric decay or growth, then the relation, so the relation or the recurrence relation is what we are interested, is that for the growth and decay is of the form Vn plus 1, so again we're using recursives, is Rvn. So R is a constant, and it's a ratio, if you like, between the two. And to get that, it's Vn plus 1 over Vn. So any particular term you get and the one before, divide that out, and that gives you your ratio. So where R is a constant, right, it's the same between each, it's the ratio between each term. And so for growth, R is bigger than 1, so then things go up. And for decay, it's less than 1, so it's going to be going down each time. All right, so there's a couple of things that we're going to look at for growth and decay. First one is compound interest. So compound interest, let me move my fonts out of the way there. So compound interest is the first thing that we are looking at here for growth, and it's an example of geometric growth, and it says there it's the usual way for interest to be calculated. So normally if you invest some money, you will then get interest on that investment over the year. That interest will be credited to your account, and then the next year's interest will be on that amount of money, not on the initial, like simple interest that's just worked on the initial amount all the time. But for compound interest, it's the amount you've got keeps going up, so your interest gets worked out on that amount. You know, that was all a bit of a waffle, and so what actually happens is things go up like that. All right, so compound interest. So Vn is the value of your initial investment, or your value of your investment after n compounding periods, I should say. R is the interest rate per compounding period. So we notice we're using another term here, compounding periods. Just depends on when it's compounding, and we'll have a look at an example in a minute. V0 is our original amount, and then of course the recurrence relation. Vn plus 1 is R times Vn. And what is R? R is our ratio, and it's related to our interest rate. So 1 plus the interest rate on 100. All right. So as I said, let's have a look at an example. So example here, we've got Fred. Fred invests $5,000. So, all right, we'll stop there. $5,000. First of all, actually, I don't need that just at the moment. Whoops. Where are we? It's better. Yep. Clear my drawings. Oh, doesn't want to behave for me. There we are. Let me rub them out then. All right. So back to here. So V0 is 5,000. At 4.5%, so R is 4.5 per annum. What with the investment after 5 years? If the interest is compounded, A yearly, B quarterly, and C monthly. All right, so the ratio. Let's work out the ratio because we can work out the ratio, and that's 1 plus 4.5 on 100. And when you do that, you get 1.045. All right, N. So it's example A then. So for A, N is 5 years. And V0, as we've got all that. So our recurrence relation is Vn plus 1 equals R, which is 1.045 times Vn. All right, so here's where we go to our calculator again. So let's go to our calculator. Remember, it's on our second page in our sequence. Haven't got any at the moment. So Vn plus 1, so looking at A, is 1.045. Squeeze that up. 1.045 times AN, and our initial value for Fred is 5,000. Don't forget to check the box, and then EXE. Oh, I didn't need the EXE, sorry. Check the box or press the EXE. Now we need to go and fill the table, press the table, there we go. So after 5 years, and remember N is the number of years, N is 5 years, so here we go, this one here, looks like he's got $6,230.90. So let's go back here. So V5 equals $6,230.90. All right. So let's say if you did it compounding quarterly. Sorry, not quarterly, compounding yearly. So just get that interest credited once every year. Now, often you get ones that you have interest being compounded more often than that. So the B is quarterly. So let's go to the next page here. So there's some things that don't change and there's some things that do change. But let's have a look at B first of all. So if we're doing it quarterly, and we've got 5 years times 4 quarters, and as you know, that's 20. So what we have is 20 compounding periods. Over that 5 years. So what that then means is that N is going to be 20. All right, because we've got 20 compounding periods. Now, our interest also, that was 4.5% per annum. Now, we need to adjust that to 4.5 divided by 4% per compounding period. Which of course is a quarter of a year. All right, so we need to change those things. So when you put that one in your calculator, you get 1.125. That'll help us find our R. So our R relates to 1 plus the 1.125 over 100. And you put that on your calculator and you get 1.01125. If you need to pause to catch up with this, you need to pause the video so that you get your notes down that you want. Make sure you do that. All right, so our Vn plus 1 then is our R, which is 1.01125 times our Vn. All right, so now we go to our calculator. And we're after V20. All right, so let's go to our calculator. And so now remember on our calculator here, we've got to change this some of this information. The information we need to change is this bit up here. Because our R is now different. Our R is now 1.01125. All right. And so then we've got to recalculate because these numbers are for the old one. On our table, there we are, we've got recalculation and we're after V20. Now this only goes down to 10, so we've got to change that. Sequence table input, so that's this one here that I did, the one with the X and the Y. It's ending at 10, we want number 20, so let's end at number 20. Go, and now it's recalculated down to number 20, and there we are, 6,253. 6253 and 80 cents. All right. So as you can see, compounding quarterly, you end up with a little bit more money. All right, part C. Let's go back just, so I wrote that. Sorry, I forgot to get off that. I'll write that down. So you can get a little bit more money. All right, than you had. Oh, I forgot some sort of digit there. What digit did I forget? I forgot the 0. All right, 6230, and now we've got 6253. All right, so it's a bit better. All right, last one, monthly. All right. So C for monthly. So monthly. So we've got 5 years times 12 months, which is 60 compounding periods. All right, so N is 60. R, well, it's 4.5% per annum, and the compounding periods every month, so there's 4.5 on 12, which is 0.375 per month. All right, so let's find our R. 1 plus the little r, which is the monthly one, 0.375 on 100, and you work that out in your calculator, and you get 1.00375. All right, so the recurrence relation for this particular, whoops, let me go back. That's better. So there's our recurrence relation. And so now we need to go to the calculator. So here we are in our calculator. Up the top here, we need to adjust that. Now it's 1.0037675. We need to do our calculation, and remember, of course, this time what we're wanting is V of 60. So we've only got 20 down there, so V of 60. We need to go up here, change that to 60, go OK, and scroll down. There we go. And so for 60, I'll write this down, then I'll switch to it, 6259.00. So there's the amount of money we've got there. You know, again, a little bit better. So the more often it's compounding, the better it is for you as the investor. All right. Okay. So that's an example of growth. We're going to have a look at an example of decay. All right. So here's an example of decay, reducing balance depreciation. So it's not just on what the initial was, a percentage of the initial, it's a percentage of what it's worth now. All right, then time goes by, and the next bit of depreciation again is what it's worth now, percentage of that. All right, and usually that we've worked out in years. It's not worked out any more often than that. Just tax is done every year, so it's worked out on a yearly basis. So the only difference between that and what we've just done is because it's decay, we've got the minus there, so it's worth less now than it was worth before. All right, so example. Here we go. Office furniture. Purchased for 6,900, and depreciates a rate of 7% per annum. What is it worth after 3 years? So let's have a look at A. So V0, 6900. Then what else do we need? Interest rate is 7% per annum. So we need the R, so the R would be 1 minus 7 on 100. And when you did that, you would get 0.93. Okay, so it's less than 1. So it's going down. So our recurrence relation, n plus 1, equals 0.93 Vn. And then we use our calculator again. So we go to our calculator, let me get to it. All right, so we're going to change a couple of things here. So first of all, we're going to change our R to 0.93. Also got to change our initial value, which because it's now 6,900 for this particular question. All right, fill in the table, and here it is. And so after 3 years is what we were after. 3 years, yep, there we go, 3 years. So V3, I'll squeeze it here. Let me go back to the calculator. V3, there it is, 5,550 and 10. 5,550 and 10 cents. All right, so there it is. That's what it's worth. Okay, so question part B says, when will the value of the furniture be less than All right, less than 5,000, so not exactly 5,000, but less than. And remember, we're working in whole years here, so let's go back to the calculator. So less than, okay, so 3 years was 5.5, 4 is 5,161.60. In year 5, it now drops underneath. All right, so remember the question says less than, and that's less than. And remember, because we only do this yearly, not parts of a year, it's whole year. So it's either 4 years or it's 5 years, and we're after the less than, and the less than occurs at 5 years. So it's less than. So for part B, 5 years. All right, so that's it for this particular lesson. So geometric growth and decay. So the exercise 8E questions that are on your work plan are what you want to do for those. And if you've got any questions, make sure you ask for an assistance, and then it will be clarified for you.